Welcome to the video lecture on VLSI design. Unit 1, Introduction to MOS transistor. So VLSI is very large scale integration. So first of all, what is an integrated circuit? So integrated circuit means many transistors are on one chip. VLSI began in 1970s where complex semiconductor and communication technologies were being developed. For example, microprocessor is a VLSI design. So microprocessors are into many products where we use every day, such as computers, laptop, tablets, smartphone, TVs, right from home appliances, domestic cards, and many speed communication networks. So transistors are the main components of microprocessors. In general, you can call VLSI technology to be branched into two. One being BJT technology and the second one being MOSFET technology. So as our requirements are becoming more and more stringent, we are also moving into a combination of the above two, which we call it as BiCMOS technology. So the same circuit may have some active elements as BJT and some as MOSFETs. So VLSI is the process of creating integrated chip by combining thousands of transistors onto a single chip. So this is a process of creating an integrated circuit on a single chip. So let us see like what are transistors and what are these MOS transistors. So to understand that, we'll have to begin with a silicon lattice. So this silicon is a semiconductor which forms the basic starting material for a large class of integrated circuits. So these are nothing but a three-dimensional lattice of atoms, which is a group 4 element. This is actually formed by covalent bonds with 4 adjacent atoms. And its conductivity can be increased by introducing small amounts of impurities into the silicon lattice, and these impurities are called as dopants. So adding the dopants is going to increase the conductivity of the material. Second basic things we need to know is about a p-n junction. So we very well know what is a p-n junction. This is nothing but a junction between a p-type and an n-type semiconductor, which is going to form a diode. So when the voltage of the p-type semiconductor called an anode is going to be raised above the n-type cathode, then the diode is forward biased and the current will flow. The other case is when the anode voltage is less than or equal to the cathode voltage, the diode is reverse biased, where the current is not going to flow. So now coming to NMOS transistors and PMOS transistors. So first of all, what is a MOS transistor? A metal oxide semiconductor which is created by superimposing several layers of conducting and insulating materials to form a sandwich-like structure. So these structures are manufactured using a series of chemical processing steps like oxidation of silicon, diffusion of impurities into the silicon to give it a certain conduction characteristics. Then we have deposition, and then lastly we have etching of the aluminum or other metals to provide interconnection. So this is carried out on a single crystal of silicon, which is a thin flat circular wafer which is around 15 to 30 centimeters in diameter. And with CMOS technology, we have two types of transistors. The first being N-type transistor, which we call it as an NMOS, and the second one being a P-type transistor, which we call it as a PMOS. So this transistor operation is based on electric field. So the devices are also called as metal oxide semiconductor field effect transistor, which is nothing but MOSFETs. So let's look on to this NMOS here. So if the gate is grounded, no current flows through the reverse bias junction, and hence the transistor will be said to be in off condition. If the gate voltage is raised, it creates an electric field that starts to attract the free electrons to the underside of the silicon SiO2 interface. So the electrons outnumber the holes and a thin region under the gate called as channel is formed. A conducting path of electron carriers is formed from the source to drain, and the current can flow in this case. So this is how an NMOS works. So in case of a PMOS transistor, when the gate is at high potential, the source and the drain regions are reverse biased, so no current flows and the transistor is off. Also in PMOS transistor, a low gate voltage inverts the channel and a conducting path of positive carriers is formed from source to drain. So the transistor is on. Here we have the transistors as switches, that is a switch depiction of a transistor. Here voltage at gate controls the path from source to drain. This is an NMOS transistor and this is a PMOS transistor. So let's see how this works as a switch. So when the gate is 0, there is no path between the drain to source. So the transistor is set to be in off condition. When the gate is on, when the gate is 1, when a voltage is supplied to the gate, then we have a path connecting the drain to source, and hence the transistor is said to be in on condition. Vice versa condition exists for a PMOS transistor. When gate is 0, the PMOS transistor is said to be in on condition. When gate is 1, we don't have a conducting path between drain to source, so the transistor is said to be in off condition. Thank you. In the next video, we will discuss about more on NMOS transistors and PMOS transistors.